Okay, so another way to check your work. Now you can look over this solution, looks good, the algebra looks great, but we can actually check this solution by graphing. Now we haven't talked a lot about graphing, okay? But we're going to take each one of these expressions and we're going to write it out as an equation in linear form. Again, we'll talk about that later, and it doesn't have to be in linear form, but it's basically in like a function form. So we have y1 is equal to 2x plus 5, y2 is equal to 13. And we want to know when those two equations are equal. So since we're solving for x, we want to figure out which x value is going to make y1 and y2 the same, keeping in mind that when we write a point, it's an x and a y. Okay, so now let's look at the graph. When we look at the graph, if we want to know when these two equations are equal to each other, well, that's just going to be when they intersect. And the x coordinate is 4. So going back to our algebra, we can clearly see that since that point, okay, at the intersection was 4, 13, these two equations intersect when x equals 4, which verifies our solution. Now, we can use graphing to check our work, but sometimes it's actually going to be a lot easier to solve using graphing. And this wasn't always the case. Computers have made this way easier. Okay. But let's take an equation like this. 2x squared plus 4x minus 9 equals the square root of 27x plus 9. We have no idea how to solve this as of right now. And even for myself, this would be somewhat challenging to do algebraically. Let's just plug it in. So we took the left side and plugged it in as one equation, took the right side, plugged it in as the other, and lo and behold, we end up with the answer 2.089. Okay, pretty easy when we go about it that way, right?